So today we're going to be talking about really the punchline of why we need to use logs. So today's lesson is section 10.6, and it's called Solving Exponential Equations. Now if you look at the previous few lessons, you know that to solve a problem like this, x plus 2 equals 5, we use subtraction because that's the inverse of adding. If you had 2x is equal to 8, you would divide because dividing is the inverse of multiplying. If you had x to the second equals 9, you would take the square root because that's the inverse of squaring. Today what we're going to see is how to solve a problem like this, where 2 to the x is equal to 7. Now we can't divide by 2 because we're not multiplying. We also can't subtract, we can't use a square root, you can't take like the x square root or anything like that. So we have to remember that the inverse of this kind of exponential equation is logarithm. All right, so the way we're going to solve an exponential equation, meaning that there's a variable in the power, is we're going to use logs. So let's actually do that problem. We had the problem 2 to the x is equal to 7. Well, just like you can multiply both sides, just like you could add on both sides, just like you could square root both sides, what we could actually do here is take the log of both sides, or take the log base 10 of both sides. On your calculator has an log button. It's kind of like the square root button. We know that square root means the second root, what number times itself. And the log button on your calculator means log base 10. So your calculator can do logs, but it only knows how to do log base 10. This is called a common log. And what we're going to do is we're going to take the common log of both sides. It's really log base 10, but if we don't write the 10 there, that's okay. We know that it's assumed to be a base 10. All right, well, looking at this problem, this is actually a power property. We could bring the x in front. And now at this point, it's x times the log of 2. Log of 2 is just a number. I could type that into my calculator. So the way we're going to finish this kind of problem is just divide both sides by the log base 10 of 2. Multiplying by log of 2, so we could divide by it. And on your calculator, you're going to type log 7. Make sure you close the parentheses. And we're going to be dividing by log 2. We always round logs 4 decimal places. And that would be the answer. We actually round right here. This is called the 10,000ths place. Goes tenths, hundredths, thousands, 10,000ths. All right, so let's try another problem. What if we had another problem that looked like this? 7 to the x plus 1 power is equal to 20. Well, we see it's an exponential equation, so we could take the log base 10 of both sides. By doing that, we could use the power property now, and remember it's x plus 1 times the log of 7. If we divide both sides by the log of 7, we just get x plus 1 is equal to the log of 20, type that into your calculator, divided by the log of 7, make sure you close parentheses, and this is 1.5395, 4 decimal places. Get the x by itself, subtract 1 on both sides, you get x is equal to 0.5395. That's how we solve a problem like that. All right, a couple more problems. How about something like this? What if it was 8 to the x plus, let's say x minus 2 power is equal to 5 to the x power? Now, after a while, all the problems look very similar. I mean, we're going to be taking the log base 10 of both sides. That frees up this x as the exponent. It turns that into multiplication, and then we know how to finish that. I'm going to bring this down, and I'm actually going to bring this down too. That's using the power property. So we get x minus 2 times the log of 8 is equal to x times the log of 5. Now, log 8 and log 5 are just numbers. We could distribute that in here, but we'll have a lot of decimals floating around. So generally what I do is I would just divide both sides by the log of 8. So we don't have to distribute, a bunch of decimal numbers. So in my calculator, I'm going to type in log 5 divided by log 8. And I'm getting x minus 2 is equal to 0.77397. So that would just be 40. X, don't forget the x there. We want to try to get all the x's on the same side, so I could subtract 1x from both sides. And I'm getting negative 0.2260. And then we could just divide both sides by the number in front of x. And we'd get x is equal to, let's see what that is. Negative 2 divided by that answer is, I'm getting 8.8486. All right, one more problem. It'll be similar to this. What if it was 3 to the x plus 1 power is equal to the 5 to the x minus 1 power? Now this is the hardest kind of problem that we would see, but we know because they're an exponential equation, we could take the log of both sides and then bring that power down so that we could work with it. Remember, we're multiplying both sides by x minus 1, so that's why it needs parentheses. I would divide both sides by one of the logs. It's going to be a little bit sloppy, but I'm confident that you guys could handle this. This is going to be an x plus 1 here. And on my calculator, I'm going to type in log 5 divided by log 3. And I'm getting 1.4650. I have to multiply that by x minus 1. And then we have to try to get all the x's on the same side. So maybe I'll bring this over with the x, and I'll bring the 1 over here. All right, so I'm going to do 1 minus 1.4650 is negative 0.465x is equal to negative 2.465. And then if we divide both sides by the number in front of x, we get x is equal to I'm getting 5.3011. That's the hardest kind of problem that we'd see at this point. For homework, what I would like you to please do is on practice 10.6. I would like you to please do numbers 2 to 12 even. Oops. All right. Thank you very much. Have a nice day.